Okay, this is the 3.7 pre-class notes. Objectives: to perform operations of adding, subtracting, multiplying, and dividing with functions, and determine domain of the functions that have been combined. So in terms of after you've done those operations, what is the domain of the new combined function? Okay, so functions can define lots of different things, but here's the main thing that you want to be aware of for this section is what can you do with functions? Well, if you have two functions, then f plus g of x means to add f of x to g of x, and f minus g of x means to take f of x and subtract g of x. F times g means to actually multiply the two functions together, and f over g means to write them as a ratio and make sure that you don't have a domain issue. So essentially, the first three, the sum, the difference, and the product, they are just going to have what we call the domains that are common to each of those. So the domain of f plus g, f minus g, and f times g are the intersection of the domains. That is, the numbers that they have in common. The quotient gets a little tricky. Because you have placed something in the denominator, you have to think of what we call domain restrictions. It is still going to be the combined domains, but there might be something extra that has to be thrown out because it's in a denominator now. And so that's what they say here. It's everything that's in that intersection. So in other words, what do the two domains have in common as long as the numbers don't create denominator issues? A polynomial function, which is just a bunch of terms added and subtracted together, like quadratics or cubics or linear functions, those are all going to have pretty much all real numbers. Functions that are not algebraic will be transcendental. We won't talk about these until the last unit, but the exponential and logarithmic are transcendental functions, which are what we're going to study in our last unit of material. So let's go ahead and get started. First of all, let's look at my first example. This says that we have f of x being negative x squared and g of x is 2x minus 1. It might be good to go ahead and note the domain of each. If it's a polynomial, there are no domain restrictions. So this is negative infinity to infinity. This one also is a polynomial. So again, no restrictions, negative infinity to infinity. So that helps us with doing parts A, B, C, and D, because to know whether or not we can actually do this problem, we need to first of all figure out what each of these operations would look like, and then we have to ask, can 3 be plugged in? So let's just figure out what f, excuse me, I backed it up. Let's figure out what f plus g would look like. Then we can worry about plugging 3 in for it. So that would be f of x plus g of x. Think of it as two separate polynomials being added together. None of these are like terms, so this is f plus g of x. And since there's no domain issues, because there is no denominator or radical, we can go ahead and plug in 3. So this would be negative 3 squared plus 2 times 3 minus 1. 3 squared is 9, but you have that negative out front, so that's negative 9 plus 6 minus 1. That would be negative 3 minus 1 more, so that is negative 4. So here's my function when I added, and there's the evaluation at 3. So this was part A. Part B of this one is to do subtraction. So you say, okay, negative x squared. When you subtract, it is better to put the second one in a parentheses because you do have to subtract the whole thing, which means you're going to distribute that. So this ends up being negative x squared minus 2x plus 1. So you do have to be careful of signs when you're subtracting. Again, no domain issues. So we plug in 3 like they asked us to. This would be negative, excuse me, not negative 3, 3 squared. I'm going to go ahead and erase this. It's already looking messy. So negative and then 3 squared, and then minus 2 times 3, and then plus 1. That would be 9, and that's a negative, so that would be negative 9 minus 6 plus 1. That's negative 15 plus 1, so that would be negative 14. Okay, now we're going to do multiplication, and then our last one will be division. So C, we're going to do f times g of x. That means you take the two functions, you multiply them together. So this would be negative 2x cubed plus x squared. So that is my function. And then I'm going to plug in 3, which again is fine because we did not create any kind of domain problems. So negative 2 times 3 cubed plus 3 squared. That would be negative 2 times 27 plus 9. That's negative 54 plus 9. So we're really subtracting those. So 54 minus 9. It's going to be a negative 45 overall. And then lastly, for this example, we want to do the division case. There's that little f. So f over g of x. So we place the f function on top of the g function. And now we have created a domain problem. So we do need to address that before we plug anything in or work this out. X cannot equal 0, so in the denominator we cannot equal 1/2, which is fine because we're going to end up plugging in 3, not 1/2. So, and again, we can't really reduce anything here, so we're going to go ahead and do the evaluation since we checked our domain. And so if we wanted to write this, by the way, that would be negative infinity to 1/2 union with 1/2 to infinity, where all the others were just all real numbers because they were polynomials. So this would be negative 3 squared over 2 times 3 minus 1. That's negative 9 over 6 minus 1. So that's negative 9 over 5. Okay, so that's that example all the way worked out. So again, not too difficult. You're just combining the functions using the 4 main operations. We'll learn about composition in class on Wednesday, so tomorrow. That one is a little bit trickier. It's our 5th operation. So for this number, we're going to do A and B part, and then we'll be done with our pre-video. We are supposed to do the addition, the subtraction, the multiplication, and the division, and then discuss the domain of the first 3, because the domain of the first 3 should be the same. Then we talk about the domain of the one where you've created a domain restriction in your denominator. So let's just work them out one at a time. So we're going to do f plus g of x, which means take the first polynomial, add it to the second one. If there's like terms, go ahead and combine them. This would be 2x squared plus x minus 3. Okay. We also want to do f minus g. So the first function minus the second one. Make sure you distribute that negative. So this time the x squareds cancel out and you're just left with x plus 3 because of that opposite sign. F times g. So we do x squared plus x times x squared minus 3. X squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. X times x squared would be positive x cubed. And x times negative 3 would be negative 3x. And you could write that in descending order if you want. You would just need to swap the 2 middle terms, but I'm okay with that. And then lastly, what would it look like if we wrote the fraction? So x squared plus x over x squared minus 3. And we're pretty much done because there is no way to reduce that. You could pull an x out of the top if you wanted to, but this is not perfect squares in the bottom, so it's not going to factor, so it doesn't help us cancel anything. So this would be another alternative to the same answer. And then part B, which I think nope, I have not done yet. The domain of the first three. So domain of f plus g, f minus g, and f times g. They're all three polynomials, so polynomials are always negative infinity to infinity. The problem is the last one. Because x squared minus 3 cannot equal 0, so this is domain of f over g, you have to figure out what would make that problem. So if we add the 3 over and then take a square root, plus or minus the square root of 3 is the problem. So this would be negative infinity to negative square root of 3, union with negative square root of 3 to positive square root of 3, union with square root of 3 to positive infinity. You just think of the whole number line where you skip those inappropriate values only. And union, remember, is how we string that together. So that's part B's answer, and this is part C. Okay? Same idea here, except now I've made your functions a little more complex. These already have domain problems from the get-go. So I'm going to go ahead and list them out. If it's a radical and it's a square root or an even root, the inside has to stay greater than or equal to 0. So we would subtract the 3 over and then divide by a negative. When you divide by a negative, you have to flip your inequality. So this would be less than or equal to 3/2. For this one, you have to do x plus 4 is greater than or equal to 0 because it's, again, a square root. So x has to be greater than or equal to negative 4. Okay, so let's do our f plus g of x, which is actually pretty boring. Since these are not like radicals, which means their insides are different, you cannot add them together. So that's all you can do. Same thing for subtraction. If they're not like radicals, I wrote that way too big. If they're not like radicals, then you cannot subtract them either. You just have to write it out. And you can't make it one big radical. That is not okay. Adding and subtracting cannot be combined unless the radical matches, and then you combine the coefficients. Let's do f times g. This one we could do a little bit more work with, because as long as our answers are real numbers, and we're going to force them to be because that's what we're talking about domain, and we're talking about functions which have real numbers only, we can multiply this together using the rule that says it can become one big radical where you times the binomial's inside. So that is a property that you can do only when multiplying. So this would be, let's see, 3x plus 12, so I'm foiling this out, minus 2x squared minus 8x. So we combine like terms and reorder. That would be the simplified version of that. And yes, I know that says that's negative, but that doesn't mean the value comes out negative for the whole radical. So there's nothing wrong with that. And then f over g. So this would be square root of 3 minus 2x over the square root of x plus 4. We don't like having radicals in our denominator, so we will rationalize it by multiplying top and bottom by the same thing. That would make the top, this guy right here, the one we just did, because you just multiply them. And the bottom would just be x plus 4. Now let's talk about the domain issue. Okay, so for domain of f plus g, f minus g, and f times g, it's a combined domain of what we call the intersection of the two domains that we have here. So we're going to have to probably draw a picture. F over g will have an extra restriction. Okay, so if I draw a number line, let's just draw it up here. Here is 3/2. The other number we were concerned with was -4, which is going to be to the left of that one. My first domain had to be less than or equal to -3/2. My second domain had to be greater than or equal to -4. You can very clearly see that the intersection is right here. That is where the domains are combined. So that means that from -4 to 3/2 is our domain for all of the first three. The problem with this one is that there is this restriction here that x cannot equal -4 anymore because of the denominator. So this one would be the same domain except we remove the possibility of being -4 by taking away its bracket. And that is it.